Hello everyone. Question is a company is providing weather data over a REST-based API to several customers. The API is hosted by Amazon API Gateway and is integrated with different AWS Lambda functions for each API operation. The company uses Amazon Route 53 for DNS and has created a resource record of weather.example.com. The company stores data for the API in Amazon DynamoDB tables. The company needs a solution that will give the API the ability to fail over to a different AWS region. Which solution will meet these requirements? Option A. Deploy a new set of Lambda functions in a new region. Update the API Gateway API to use an edge-optimized API endpoint with Lambda functions from both regions as targets. Convert the DynamoDB tables to global tables. Deploy a new API Gateway API and Lambda functions in another region. Change the Route 53 DNS record to a multi-value answer. Add both API Gateway APIs to the answer. Enable target health monitoring. Convert the DynamoDB tables to global tables. Option C. Deploy a new API Gateway API and Lambda functions in another region. Change the Route 53 DNS record to a failover record. Enable target health monitoring. Convert the DynamoDB tables to global tables. Option D. Deploy a new API Gateway API in a new region. Change the Lambda functions to global functions. Change the Route 53 DNS records to a multi-value answer. Add both API Gateway APIs to the answer. Enable target health monitoring. Convert the DynamoDB tables to global tables. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is a company is running a two-tier wave-based application in an on-premises data center. The application layer consists of a single server running a stateful application. The application connects to a PostgreSQL database running on a separate server. The application's user base is expected to grow significantly, so the company is migrating the application and database to AWS. The solution will use Amazon Aurora PostgreSQL, Amazon EC2 auto-scaling, and elastic load balancing. Which solution will provide a consistent user experience that will allow the application and database tiers to scale? Option A. Enable Aurora auto-scaling for Aurora replicas. Use a network load balancer with the least outstanding requests, routing algorithm, and sticky sessions enabled. Option B. Enable Aurora auto-scaling for Aurora writers. Use an application load balancer with the round-robin routing algorithm and sticky sessions enabled. Option C. Enable Aurora auto-scaling for Aurora replicas. Use an application load balancer with the round-robin routing and sticky sessions enabled. Option D. Enable Aurora scaling for Aurora writers. Use a network load balancer with the least outstanding requests, routing algorithm, and sticky sessions enabled. Correct answer is option C. Question is a company uses a service to collect metadata from applications that the company hosts on premises. Consumer devices such as TVs and internet radios access the application. Many older devices do not support certain HTTP headers and exhibit errors when these headers are present in responses. The company has configured an on-premises load balancer to remove the unsupported headers from responses sent to older devices which the company identified by the user agent headers. The company wants to migrate the service to AWS, adopt serverless technologies, and retain the ability to support the older devices. The company has already migrated the applications into a set of AWS Lambda functions. Which solution will meet these requirements? Option A. Create an Amazon CloudFront distribution for the metadata service. Create an application load balancer ALB. Configure the CloudFront distribution to forward requests to the ALB. Configure the ALB to invoke the correct Lambda function for each type of request. Create a CloudFront function to remove the problematic headers based on the value of the user agent header. Option B. Create an Amazon API Gateway REST API for the metadata service. Configure API Gateway to invoke the correct Lambda function for each type of request. Modify the default gateway responses to remove the problematic headers based on the value of the user agent header. Option C. Create an Amazon API Gateway HTTP API for the metadata service. Configure API Gateway to invoke the correct Lambda function for each type of request. Create a response mapping template to remove the problematic headers based on the value of the user agent. Associate the response data mapping with the HTTP API. Option D. Create an Amazon CloudFront distribution for the metadata service. Create an application load balancer ALB. Configure the CloudFront distribution to forward requests to the ALB. Configure the ALB to invoke the correct Lambda function for each type of request. Create a Lambda at edge function that will remove the problematic headers in response to viewer requests based on the value of the user agent header. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is running a traditional web application on Amazon EC2 instances. The company needs to refactor the application as microservices that run on containers. Separate versions of the application exist in two distinct environments: production and testing. Load of the application is variable, but the minimum load and the maximum load are known. A solution architect needs to design the updated application with a serverless architecture that minimizes operational complexity. Which solution will meet these requirements most cost effectively? Option A. Upload the container images to AWS Lambda as functions. Configure a concurrency limit for the associated Lambda functions to handle the expected peak load. Configure two separate Lambda integrations within Amazon API Gateway, one for production and one for testing. Option B. Upload the container images to Amazon Elastic Container Registry, Amazon ECR. Configure two auto-scaled Amazon Elastic Container Service, Amazon ECS clusters with the Fargate launch type to handle the expected load. Deploy tasks from the ECR images. Configure two separate application load balancers to direct traffic to the ECS clusters. Option C. Upload the container images to Amazon Elastic Container Registry Amazon ECR. Configure two auto-scaled Amazon Elastic Kubernetes Service Amazon EKS clusters with the Fargate launch type to handle the expected load. Deploy tasks from the ECR images. Configure two separate application load balancers to direct traffic to the EKS clusters. Option D. Upload the container images to AWS Elastic Beanstalk. In Elastic Beanstalk, create separate environments and deployments for production and testing. Configure two separate application load balancers to direct traffic to the Elastic Beanstalk deployments. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has a multi-tier wave application that runs on a fleet of Amazon EC2 instances behind an application load balancer ALB. The instances are in an auto-scaling group. The ALB and the auto-scaling group are replicated in a backup AWS region. The minimum value and the maximum value for the auto-scaling group are set to 0. An Amazon RDS multi-AZ DB instance stores the application's data. The DB instance has a read replica in the backup region. The application presents an endpoint to end users by using an Amazon Route 53 record. The company needs to reduce its RTO to less than 15 minutes by giving the application the ability to automatically fail over to the backup region. The company does not have a large enough budget for an active-active strategy. What should a solution architect recommend to meet these requirements? Option A. Reconfigure the application's Route 53 record with a latency-based routing policy that load balances traffic between the two ALBs. Create an AWS Lambda function in the backup region to promote the read replica and modify the auto-scaling group values. Create an Amazon CloudWatch alarm that is based on the HTTP code _target _5xx count metric for the ALB in the primary region. Configure the CloudWatch alarm to invoke the Lambda function. Option B. Create an AWS Lambda function in the backup region to promote the read replica and modify the auto-scaling group values. Configure Route 53 with a health check that monitors the wave applications and sends an Amazon Simple Notification Service Amazon SNS notification to the Lambda function when the health check status is unhealthy. Update the application's Route 53 record with a failover policy that routes traffic to the ALB in the backup region when a health check failure occurs. Option C. Configure the auto-scaling group in the backup region to have the same values as the auto-scaling group in the primary region. Reconfigure the application's Route 53 record with a latency-based routing policy that load balances traffic between the two ALBs. Remove the read replica. Replace the read replica with a standalone RDS DB instance. Configure cross-region replication between the RDS DB instances by using snapshots and Amazon S3. Option D. Configure an endpoint in AWS Global Accelerator with the two ALBs as equal weighted targets. Create an AWS Lambda function in the backup region to promote the read replica and modify the auto-scaling group values. Create an Amazon CloudWatch alarm that is based on the HTTP code _target _5xx count metric for the ALB in the primary region. Configure the CloudWatch alarm to invoke the Lambda function. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a retail company is operating its e-commerce application on AWS. The application runs on Amazon EC2 instances behind an application load balancer ALB. The company uses an Amazon RDS DB instance as the database backend. Amazon CloudFront is configured with one origin that points to the ALB. Static content is cached. Amazon Route 53 is used to host all public zones. After an update of the application, the ALB occasionally returns a 502 status code that is bad gateway error. The root cause is malformed HTTP headers that are returned to the ALB. The web page returns successfully when a solutions architect reloads the web page immediately after the error occurs. While the company is working on the problem, the solutions architect needs to provide a custom error page instead of the standard ALB error page to visitors. Which combination of steps will meet this requirement with the least amount of operational overhead? Choose two options. Option A. Create an Amazon S3 bucket. Configure the S3 bucket to host a static web page. Upload the custom error pages to Amazon S3. Option B. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response target failed health checks is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a publicly accessible web server. Option C. Modify the existing Amazon Route 53 records by adding health checks. Configure a fallback target if the health check fails. Modify DNS records to point to a publicly accessible web page. Option D. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response ELB.internal error is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a public accessible web server. Option E. Add a custom error response by configuring a CloudFront custom error page. Modify DNS records to point to a publicly accessible web page. Correct answer is option A and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company wants to use a third-party software as a service SaaS application. The third-party SaaS application is consumed through several API calls. The third-party SaaS application also runs on AWS inside a VPC. The company will consume the third-party SaaS application from inside a VPC. The company has internal security policies that mandate the use of private connectivity that does not traverse the internet. No resources run in the company VPC are allowed to be accessed from outside the company's VPC. All permissions must conform to the principles of least privilege. Which solution meets these requirements? Option A. Create an AWS Private Link Interface VPC endpoint. Connect this endpoint to the endpoint service that the third-party SaaS application provides. Create a security group to limit the access to the endpoint. Associate the security group with the endpoint. Option B. Create an AWS site-to-site VPN connection between the third-party SaaS application and the company VPC. Configure network ACLs to limit access across the VPN tunnels. Option C. Create a VPC peering connection between the third-party SaaS application and the company VP. Update route tables by adding the needed routes for the peering connection. Option D. Create an AWS private link endpoint service. Ask the third-party SaaS provider to create an interface VPC endpoint for this endpoint service. Grant permissions for the endpoint service to the specific account of the third-party SaaS provider. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company uses on-premises data analytics platform. The system is highly available in a fully redundant configuration across 12 servers in the company's data center. The system runs scheduled jobs both hourly and daily in addition to one-time requests from users. Scheduled jobs can take between 20 minutes and 2 hours to finish running and have tight SLAs. The scheduled jobs account for 65% of the system uses. User jobs typically finish running in the less than 5 minutes and have no SLA. The user jobs account for 35% of system uses. During the system failures, scheduled jobs must continue to meet SLAs. However, user jobs can be delayed. A solution architect needs to move the system to Amazon EC2 instances and adopt a consumption-based model to reduce cost with no long-term commitments. The solution must maintain high availability and must not affect the SLAs. Which solution will meet these requirements most cost effectively? Option A. Split the 12 instances across 2 availability zones in the chosen AWS region. Run 2 instances in each availability zone as on-demand instances with capacity reservations. Run 4 instances in each availability zone as spot instances. Option B. Split the 12 instances across 3 availability zones in the chosen AWS region. In one of the availability zones, run all 4 instances as on-demand instances with capacity reservations. Run the remaining instances as spot instances. Option C. Split the 12 instances across 3 availability zones in the chosen AWS region. Run 2 instances in each availability zone as on-demand instances with a savings plan. Run 2 instances in each availability zone as spot instances. Option D. Split the 12 instances across 3 availability zones in the chosen AWS region. Run 3 instances in each availability zone as on-demand instances with capacity reservations. Run 1 instance in each availability zone as a spot instance. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a security engineer determined that an existing application retrieves credentials to an Amazon RDS for MySQL database from an encrypted file in Amazon S3. For the next version of the application, the security engineer wants to implement the following application design changes to improve security. The solution architect will generate a cloud formation template to deploy the application. Which resources specified in the cloud formation template will meet the security engineer's requirements with the least amount of operational overhead? Option A. Generate the database password as a secret resource using AWS Secrets Manager. Create an AWS Lambda function resource to rotate the database password. Specify a secrets manager rotation schedule resource to rotate the database password every 90 days. Option B. Generate the database password as a secure string parameter type using AWS Systems Manager Parameter Store. Create an AWS Lambda function resource to rotate to the database password. Specify a parameter store rotation schedule resource to rotate the database password every 90 days. Option C. Generate the database password as a secret resource using AWS Secrets Manager. Create an AWS Lambda function resource to rotate the database password. Create an Amazon Event Bridge scheduled rule resource to trigger the Lambda function password rotation every 90 days. Option D. Generate the database password as a secure string parameter type using AWS Systems Manager Parameter Store. Specify an AWS AppSync data source resource to automatically rotate the database password every 90 days. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is storing data in several Amazon DynamoDB tables. A solutions architect must use a serverless architecture to make the data accessible publicly through a simple API over HTTPS. The solution must scale automatically in response to demand. Which solutions meet these requirements? Choose two options. Option A. Create an Amazon API Gateway REST API. Configure this API with direct integrations to DynamoDB by using API Gateway's AWS integration type. Option B. Create an Amazon API Gateway HTTP API. Configure this API with direct integrations to DynamoDB by using API Gateway's AWS integration type. Option C. Create an Amazon API Gateway HTTP API. Configure this API with integrations to AWS Lambda functions that return data from the DynamoDB tables. Option D. Create an accelerator in AWS Global Accelerator. Configure this accelerator with AWS Lambda at Edge function integrations that return data from the DynamoDB tables. Option E. Create a network load balancer. Configure listener rules to forward requests to the appropriate AWS Lambda functions. Correct answer is option C and option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has registered 10 new domain names. The company uses the domains for online marketing. The company needs a solution that will redirect online visitors to a specific URL for each domain. All domains and target URLs are defined in a JSON document. All DNS records are managed by Amazon Route 53. A solutions architect must implement a redirect service that accepts HTTP and HTTPS requests. Which combination of steps should the solutions architect take to meet these requirements with the least amount of operational effort? Choose three options. Option A. Create a dynamic web page that runs on an Amazon EC2 instance. Configure the web page to use the JSON document in combination with the event message to look up and respond with a redirect URL. Option B. Create an application load balancer that includes HTTP and HTTPS listeners. Option C. Create an AWS Lambda function that uses the JSON document in combination with the event message to look up and respond with a redirect URL. Option D. Use an Amazon API Gateway API with a custom domain to publish an AWS Lambda function. Option E. Create an Amazon CloudFront distribution. Deploy a Lambda at Edge function. Option F. Create an SSL certificate by using AWS Certificate Manager ACM. Include the domains as subject alternative names. Correct answer is option C, E, and option F. Question is, a company stores sales transaction data in Amazon DynamoDB tables. To detect anomalous behaviors and respond quickly, all changes to the items stored in the DynamoDB tables must be logged within 30 minutes. Which solution meets these requirements? Option A. Copy the DynamoDB tables into Apache Hive tables on Amazon EMR every hour and analyze them or anomalous behaviors. Send Amazon SNS notifications when anomalous behaviors are detected. Option B. Use AWS CloudTrail to capture all the APIs that change the DynamoDB tables. Send SNS notifications when anomalous behaviors are detected using CloudTrail event filtering. Option C. Use Amazon DynamoDB streams to capture and send updates to AWS Lambda. Create a Lambda function to output records to Amazon Kinesis data streams. Analyze any anomalies with Amazon Kinesis Data Analytics. Send SNS notifications when anomalous behaviors are detected. Option D. Use event patterns in Amazon CloudWatch events to capture DynamoDB API call events with an AWS Lambda function as a target to analyze behavior. Send SNS notifications when anomalous behaviors are detected. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company has a three-tier application running on AWS with a web server, an application server, and an Amazon RDS MySQL DB instance. A solutions architect is designing a disaster recovery OR solution with an RPO of 5 minutes. Which solution will meet the company's requirements? Option A. Configure AWS Backup to perform cross-region backups of all servers every 5 minutes. Reprovision the three tiers in the DR region from the backups using AWS CloudFormation in the event of a disaster. Option B. Maintain another running copy of the web app and application server stack in the DR region using AWS CloudFormation reel detection. Configure cross-region snapshots to the DB instance to the DR region every 5 minutes. In the event of a disaster, restore the DB instance using the snapshot in the DR region. Option C. Use the Amazon EC2 image builder to create and copy AMIs of the Wave and application server to both the primary and DR regions. Create a cross-region read replica of the DB instance in the DR region. In the event of a disaster, promote the read replica to become the master and reprovision the servers with AWS Cloud Formation using the AMIs. Option D. Create AMIs of the Wave and application servers in the DR region. Use scheduled AWS Glue jobs to synchronize the DB instance with another DB instance in the DR region. In the event of a disaster, switch to the DB instance in the DR region and reprovision the server with the AWS Cloud Formation using the AMIs. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is an e-commerce website running on AWS uses an Amazon RDS for MySQL DB instance with general purpose SSD storage. The developers choose an appropriate instance type based on demand and configured 100 GB of storage with a sufficient amount of free space. The website was running smoothly for a few weeks until a marketing campaign launched. On the second day of the campaign, users reported long wait times and timeouts. Amazon CloudWatch metrics indicated that both reads and the writes to the DB instance were experiencing long response times. The CloudWatch metrics shows 40% to 50% of CPU and memory utilization, and sufficient free storage space is still available. The application server logs show no evidence of database connectivity issues. What could be the root cause of the issue with the marketing campaign? Option A. It exhausted the I/O credit balance due to provisioning low disk storage during the setup phase. Option B. It caused the data in the tables to change frequently, requiring indexes to the rebuild to optimize queries. Option C. It exhausted the maximum number of allowed connections to the database instance. Option D. It exhausted the network bandwidth available to the RDS for MySQL DB instance. Correct answer is option A. Question is, a company hosts a web application that turns on a group of Amazon EC2 instances that are behind an application load balancer ALB in a VPC. The company wants to analyze the network payloads to reverse engineer a sophisticated attack of the application. Which approach should the company take to achieve this goal? Option A. Enable VPC flow logs. Store the flow logs in an Amazon S3 buckets for analysis. Option B. Enable traffic mirroring on the network interface of the EC2 instances. Send the mirror traffic to a target for storage and analysis. Option C. Create an AWS WAF Wave ACL and associate it with the ALB. Configure AWS WAF logging. Option D. Enable logging for the ALB. Store the logs in an Amazon S3 bucket for analysis. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is a startup company hosts a fleet of Amazon EC2 instances in private subnets using the latest Amazon Linux 2 AMI. The company's engineers rely heavily on SSH access to the instances for troubleshooting. The company's existing architecture includes the following: a VPC with private and public subnets, and a NAT gateway site-to-site VPN for connectivity with the on-premises environment, EC2 security groups with direct SSH access from the on-premises environment. The company needs to increase security controls around SSH access and provide auditing of commands executed by the engineers. Which strategy should a solution architect use? Option A: Install and configure EC2 Instance Connect on the fleet of EC2 instances. Remove all security group rules attached to EC2 instances that allow inbound TCP on port 22. Advise the engineers to remotely access the instances by using the EC2 Instance Connect CLI. Option B: Update the EC2 security groups to only allow inbound TCP on port 22 to the IP addresses of the engineer's devices. Install the Amazon CloudWatch agent on all EC2 instances and send operating system audit logs to CloudWatch logs. Option C: Update the EC2 security groups to only allow inbound TCP on port 22 to the IP addresses of the engineer's devices. Enable AWS config for EC2 security group resource changes. Enable AWS Firewall Manager and apply a security group policy that automatically remediates changes to the rules. Option D: Create an IAM role with the Amazon SSM Managed Instance Core Managed policy attached. Attach the IAM role to all the EC2 instances. Remove all security group rules attached to the EC2 instances that allow inbound TCP on port 22. Have the engineers install the AWS Systems Manager Session Manager plugin for their devices and remotely access the instances by using the Start Session API call from the System Manager. Correct answer is option D. Question is: a company has an internal application running on AWS that is used to track and process shipments in the company's warehouse. Currently, after the system receives an order, it emails the staff the information needed to ship a package. Once the package is shipped, the staff replies to the email and the order is marked as shipped. The company wants to stop using email in the application and move to a serverless application model. Which architecture solution meets these requirements? You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Option A: Use AWS Batch to configure the different tasks required to ship a package. Have AWS Batch trigger an AWS Lambda function that creates and prints a shipping label. Once that label is scanned as it leaves the warehouse, have another Lambda function move the process to the next step in the AWS batch job. Option B: When a new order is created, store the order information in Amazon SQS. Have AWS Lambda check the queue every 5 minutes and process any needed work. When an order needs to be shipped, have Lambda print the label in the warehouse. Once the label has been scanned as it leaves the warehouse, have an Amazon EC2 instance update Amazon SOS. Option C. Update the application to store new order information in Amazon DynamoDB. When a new order is created, trigger an AWS step functions workflow, mark the orders as in progress, and print a package label to the warehouse. Once the label has been scanned and fulfilled, the application will trigger an AWS Lambda function that will mark the order as shipped and complete the workflow. Option D. Store a new order information in Amazon EFS. Have instances pull the new information from the NFS and send that information to printers in the warehouse. Once the label has been scanned as it leaves the warehouse, have Amazon API Gateway call the instances to remove the order information from Amazon EFS. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a finance company is running its business critical application on current generation Linux EC2 instances. The application includes a self-managed MySQL database performing heavy I/O operations. The application is working fine to handle a moderate amount of traffic during the month. However, it slows down during the final 3 days of each month due to month-end reporting. Even though the company is using elastic load balancers and auto-scaling within its infrastructure to meet the increased demand. Which of the following actions would allow the database to handle the month-end load with the least impact on performance? Option A. Pre-warming elastic load balancers using a bigger instance type, changing all Amazon EBS volumes to GP2 volumes. Option B. Performing a one-time migration of the database cluster to Amazon RDS and creating several additional read replicas to handle the load during end of month. Option C. Using Amazon CloudWatch with AWS Lambda to change the type, size, or IOPS of Amazon EBS volumes in the cluster based on a specific CloudWatch metric. Option D. Replacing all existing Amazon EBS volumes with the new PI OPS volumes that have the maximum available storage size and I/O per second by taking snapshots before the end of the month and reverting back afterwards. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a solution architect is building a web application that uses an Amazon RDS for PostgreSQL DB instance. The DB instance is expected to receive many more reads than writes. The solutions architect needs to ensure that the large amount of read traffic can be accommodated and that the DB instance is highly available. Which steps should the solution architect take to meet these requirements? Select three options. Option A. Create multiple read replicas and put them into an auto-scaling group. Option B. Create multiple read replicas in different availability zones. Option C. Create an Amazon Route 53 hosted zone and a record set for each read replica with a TTL and a weighted routing policy. Option D. Create an application load balancer ALB and put the read replicas behind the ALB. Option E. Configure an Amazon CloudWatch alarm to detect a failed read replica. Set the alarm to directly invoke an AWS Lambda function to delete its Route 53 record set. Option F. Configure an Amazon Route 53 health check for each read replica using its endpoint. Correct answer is option B, C, and option F. Question is, a company needs to run a software package that has a license that must be run on the same physical host for the duration of its use. The software package is only going to be used for 90 days. The company requires patching and restarting of all instances every 30 days. How can these requirements be met using AWS? Option A. Run a dedicated instance with auto placement disabled. Option B. Run the instance on a dedicated host with host affinity set to host. Option C. Run an on-demand instance with a reversed instance to ensure consistent placement. Option D. Run the instance on a licensed host with the termination set for 90 days. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a solution architect is designing an AWS account structure for a company that consists of multiple terms. All the team will work in the same AWS region. The company needs a VPC that is connected to the on-premises network. The company expects less than 50 Mbps of total to and from the on-premises network. Which combination of steps will meet these requirements most cost effectively? Select two options. Option A. Create an AWS CloudFormation template that provisions a VPC and the required subnets. Deploy the template to each AWS account. Option B. Create an AWS CloudFormation template that provisions a VPC and the required subnets. Deploy the template to a shared services account. Share the subnets by using AWS Resources Access Manager. Option C. Use AWS Transit Gateway along with an AWS site-to-site VPN for connectivity to the on-premises network. Share the Transit Gateway by using AWS Resource Access Manager. Option D. Use AWS site-to-site VPN for connectivity to the on-premises network. Option E. Use AWS Direct Connect for connectivity to the on-premises network. Correct answer is option B and option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company wants to deploy an AWS WAF solutions to manage AWS WAF rules across multiple AWS accounts. The accounts are managed under different OUs in AWS organizations. Administrators must be able to add or remove accounts or OUs from managed AWS WAF rule sets as needed. Administrators also must have the ability to automatically update and remediate non-compliant AWS WAF rules in all accounts. Which solution meets these requirements with the least amount of operational overhead? Option A. Use AWS Firewall Manager to manage AWS WAF rules across accounts in the organization. Use an AWS Systems Manager parameter to store account numbers and OUs to manage. Update the parameter as needed to add or remove accounts or OUs. Use an Amazon Event Bridge, that is Amazon CloudWatch Events rule, to identify any changes to the parameter and to invoke an AWS Lambda function to update the security policy in the Firewall Manager administrative account. Option B. Deploy an organization-wide AWS config rule that requires all resources in the selected OUs to associate the AWS WAF rules. Deploy automated remediation actions by using AWS Lambda to fix non-compliant resources. Deploy AWS WAF rules by using an AWS CloudFormation stack set to target the same OUs where the AWS config rule is applied. Option C. Create AWS WAF rules in the management account of the organization. Use AWS Lambda environment variables to store account numbers and OUs to manage. Update environment variables as needed to add or remove accounts or OUs create. Cross-account IAM roles in member accounts. Assume the roles by using AWS Security Token Service AWS STS in the Lambda function to create and update AWS WAF rules in the member accounts. Option D. Use AWS Control Tower to manage AWS WAF rules across accounts in the organization. Use AWS Key Management Service AWS KMS to store account numbers and OUs to manage, update AWS KMS as needed to add or remove accounts or OUs. Create IAM users in member accounts. Allow AWS Control Tower in the management account to use the access key and secret access key to create and update AWS WAF rules in the member accounts. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a data analytics company has an Amazon Redshift cluster that consists of several reserved nodes. The cluster is experiencing unexpected bursts of users because a team of employees is compiling a deep audit analysis report. The queries to generate the report are complex read queries and are CPU intensive. Business requirements dictate that the cluster must be able to service, read, and write queries at times. A solution architect must devise a solution that accommodates the burst of users. Which solution meets these requirements most cost effectively? Option A. Provision an Amazon EMR duster offload the complex data processing tasks. Option B. Deploy an AWS Lambda function to add capacity to the Amazon Redshift cluster by using a classic resize operation when the cluster's CPU metrics in Amazon CloudWatch reach 80%. Option C. Deploy an AWS Lambda function to add capacity to the Amazon Redshift cluster by using an elastic resize operation when the cluster's CPU metrics in Amazon CloudWatch reach 80%. Option D. Turn on the concurrency scaling feature for the Amazon Redshift cluster. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, an online magazine will launch its latest edition this month. This edition will be the first to be distributed globally. The magazine's dynamic website currently uses an application load balancer in front of the web tier, a fleet of Amazon EC2 instances for web and application servers. and Amazon Aurora MySQL. Portions of the website includes static content and almost all traffic is read-only. The magazine is expecting a significant spike in internet traffic when the new edition is launched. Optimal performance is a top priority for the week following the launch. Which combination of steps should a solution architect take to reduce system response and for a global audience? Select two options. Option A, use logical cross-region replication to replicate the Aurora MySQL database to a secondary region. Replace the web servers with Amazon S3. Deploy S3 buckets in cross-region replication mode. Option B, ensure the web and application tiers are each in auto-scaling groups. Introduce an AWS Direct Connect connection. Deploy the web and application tiers in regions across the world. Option C, migrate the database from Amazon Aurora to Amazon RDS for MySQL. Ensure all three of the application tiers, web, application, and database are in private subnets. Option D, use an Aurora Global database for physical cross-region replication. Use Amazon S3 with cross-region replication for static content and resources. Deploy the web and application tiers in regions across the world. Option E, introduce Amazon Route 53 with latency-based routing and Amazon CloudFront distributions. Ensure the web and application tiers are each in auto-scaling groups. Correct answer is option D and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is collecting a large amount of data from a fleet of IoT devices. Data is stored as optimized raw columnar ORC files in the Head-Off Distributed File Systems HDFS on a persistent Amazon EMR cluster. The company's data analytics team queries the data by using SQL in Apache. Presto deployed on the same EMR cluster queries scan large amounts of data, always run for less than 15 minutes and run only between 5 p.m. and 10 p.m. The company is concerned about the high cost associated with the current solution. A solution architect must propose the most cost-effective solution that will allow SQL data queries. Which solution will meet these requirements? Option A, store data in Amazon S3. Use Amazon Redshift Spectrum to query data. Option B, store data in Amazon S3. Use the AWS Glue Data Catalog and Amazon Athena to query data. Option C, store data in EMR file system EMRFS. Use Presto in Amazon EMR to query data. Option D, store data in Amazon Redshift using Amazon Redshift to query data. Correct answer is option D. Question is, a company has a media metadata extraction pipeline running on AWS. Notifications containing a reference to a file Amazon S3 are sent to an Amazon Simple Notification Service Amazon SNS topic. The pipeline consists of a number of AWS Lambda functions that are subscribed to the SNS topic. The Lambda functions extract the S3 file and write metadata to an Amazon RDS PostgreSQL DB instance. Users report that updates to the metadata are sometimes slow to appear or are lost. During these times, the CPU utilization on the database is high and the number of failed Lambda invocations increases. Which combination of actions should a solutions architect take to resolve this issue? Select two options. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Now the options are enable message. Option A, enable message delivery status on the SNS topic. Configure the SNS topic delivery policy to enable retries with exponential backoff. Option B, create an Amazon Simple Queue service, Amazon SOS FIFO queue and subscribe the queue to the SNS topic. Configure the Lambda functions to consume messages from the SQS queue. Option C, create an RDS proxy for the RDS instance. Update the Lambda functions to connect to the RDS instance using the proxy. Option D, enable the RDS data API for the RDS instance. Update the Lambda functions to connect to the RDS instance using the data API. Option E, create an Amazon Simple Queue service, Amazon SQS standard queue for each Lambda function and subscribe the queues to the SNS topic. Configure the Lambda functions to consume messages from their respective SQS queue. Correct answer is option C and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company plans to refactor a monolithic application into a modern application designed, deployed or AWS. The CI/CD pipeline needs to be upgraded to support the modern design for the application with the following requirements. It should allow changes to be released several times every hour. It should be able to roll back the changes as quickly as possible. Which design will meet these requirements? Option A, deploy a CI/CD pipeline that incorporates AMIs to contain the applications and their configurations. Deploy the application by replacing Amazon EC2 instances. Option B, specify AWS Elastic Beanstalk to Sage in a secondary environment as the deployment target for the CI/CD pipeline of the application. To deploy, swap the staging and production environment URLs. Option C, use AWS System Manager to reprovision the infrastructure for each deployment. Update the Amazon EC2 user data to pull the latest code artifact from Amazon S3 and use Amazon Route 53 weighted routing to point to the new environment. Option D, roll out at application updates as span off an auto-scaling event using pre-built AMIs. Use new versions of the AMIs to add instances and phase out all instances that use the previous AMI versions with the configure termination policy during a deployment event. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a software development company has multiple engineers who are working remotely. The company is running Active Directory Domain Services ADDS on an Amazon EC2 instance. The company's security policy states that all internal non-public services that are deployed in a VPC must be accessible through a VPN. Multi-factor authentication MFA must be used for access to a VPN. When should a solution architect do to meet these requirements? Option A. Create an AWS site-to-site VPN connection. Configure integration between a VPN and ADDS. Use an Amazon Workspaces client with MFA support enabled to establish a VPN connection. Option B. Create an AWS client VPN endpoint. Create an AD connector directory for integration with ADDS. Enable MFA for AD connector. Use AWS client VPN to establish a VPN connection. Option C. Create multiple AWS site-to-site VPN connections by using AWS VPN Cloud Hub. Configure integration between AWS VPN Cloud Hub and ADDS. Use AWS COV4OT to establish a VPN connection. Option D. Create an Amazon WorkLink endpoint. Configure integration between Amazon WorkLink and ADDS. Enable MFA in Amazon WorkLink and use AWS Client VPN to establish a VPN connection. Correct answer is option B. Question is, a company runs a software as a service SaaS application on AWS. The application commits of AWS Lambda function and an Amazon RDS for MySQL multi-agent database. During market events, the application has a much higher workload than normal users. Users notice slow response time during the peak periods because of many database connections. The company needs to improve the scalable performance and availability of the database. Which solution meets these requirements? Option A. Create an Amazon CloudWatch alarm action that triggers a Lambda function to add an Amazon RDS for MySQL read replica when resource utilization hits a threshold. Option B. Migrate the database to Amazon Aurora and add a read replica. Add a database connection pool outside of the Lambda function. Option C. Migrate the database to Amazon Aurora and add a read replica. Use Amazon Route 53 weighted records. Option D. Migrate the database to Amazon Aurora and add an Aurora replica. Configure Amazon RDS proxy to manage database connection pools. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a solutions architect must update an application environment within AWS Elastic Beanstalk using a with green deployment methodology. The solution architect creates an environment that is identical to the existing application environment and deploys the application to the new environment. What should be done next to complete the update? Option A. Redirect to the new environment using Amazon Route 53. Option B. Select the swap environment URLs option. Option C. Replace the auto-scaling launch configuration. Option D. Update the DNS records to point to the green environment. Correct answer is option B. Question is, a company is processing videos in the AWS cloud by using Amazon EC2 instances in an auto-scaling group. It takes 30 minutes to process a video. Several EC2 instances scale in and out depending on the number of videos in an Amazon Simple Queue service, Amazon SQS queue. The company has configured the SQS queue with a redrive policy that specifies a target dead letter queue and a max receive count of 1. The company has set the visibility timeout for the SQS queue to 1 hour. The company has set up an Amazon CloudWatch alarm to notify the deployment team when there are messages in the dead letter queue. Several times during the day, the deployment team receives notification that messages are in the dead letter queue and that videos have been processed properly. An investigation finds no errors in the application logs. How can the company solve this problem? Option A, turn on termination protection for the EC2 instances. Option B, update the visibility timeout for the SOS queue to 3 hours. Option C, configure scale-in protection for the instances during processing. Option D, update the redrive policy and set max receive count to 0. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company is launching a web-based application in multiple regions around the world. The application consists of both static content stored in a private Amazon S3 bucket and Dyna ECS containers behind an application load balancer ALB. The company requires that the static and dynamic application content be accessible through Amazon CloudFront only. Which combination of steps should a solution architect recommend to restrict direct content access to CloudFront? Select 3 options. Option A, create a wave ACL in WAS WAF with a rule to validate the presence of a custom header and associate the wave ACL with the ALB. Option B, create a wave ACL in AWS WAF with a rule to validate the presence of a custom header and associate the wave ACL with the CloudFront distribution. Option C, configure CloudFront to add a custom header to origin requests. Option D, configure the ALB to add a custom header to HTTP requests. Option E, update the S3 bucket ACL to allow access from the CloudFront distribution only. Option F, create a CloudFront Origin Access Identity OAI and add it to the CloudFront distribution. Update the S3 bucket policy to allow access to the OAI only. Correct answer is option A, C and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company has more than 10,000 sensors that send data to an on-premises Apache Kafka server by using the message queuing telemetry transport MQTT protocol. The on-premises Kafka server transforms the data and then stores the results as objects in an Amazon S3 bucket. Recently, the Kafka server crashed. The company lost sensor data while the server was being restored. A solution architect must create a new design on AWS that is highly available and scalable to prevent a similar occurrence. Which solution will meet these requirements? Option A, launch 2 Amazon EC2 instances to host the Kafka server in active and standby configuration across 2 availability zones. Create a domain name in Amazon Route 53. Create a Route 53 failover policy. Route the sensors to send the data to the domain name. Option B, migrate the on-premises Kafka server to Amazon Managed Streaming for Apache Kafka Amazon MSK. Create a network load balancer (NLB) that points to the Amazon MSK broker. Enable NLB health checks. Route the sensors to send the data to the NLB. Option C. Deploy AWS IoT core and connect it to Amazon Kinesis data firehose delivery stream. Use an AWS Lambda function to handle data transformation. Route the sensors to send the data to AWS IoT core. Option D. Deploy AWS IoT core and launch an Amazon EC2 instance to host the Kafka server. Configure AWS IoT core to send the data to the EC2 instance. Route the sensors to send the data to AWS IoT core. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a solutions architect has deployed a web application that serves users across two AWS regions under a custom domain. The application uses Amazon Route 53 latency-based routing. The solutions architect has associated weighted record sets with a pair of web servers in separate availability zones for each region. The solutions architect runs a disaster recovery scenario when all the web servers in one region are stopped. Route 53 does not automatically redirect users to the other region. Which of the following are possible root cause of this issue? Select two options. Option A. The wait for the region where the web servers were stopped is higher than the wait for the other region. Option B. One of the web servers in the secondary region did not pass the HTTP health check. Option C. Latency resource record sets cannot be used in the combination with the weighted resource record sets. Option D. The setting to evaluate target health is not returned on for the latency aliases resource record set that is associated with the domain in the region where the web servers were stopped. Option E. An HTTP health check has not been set up for one or more of the weighted resource record sets associated with the stopped web servers. Correct answer is option D. Question is, a company uses multiple AWS accounts in a single AWS region. A solutions architect is designing a solution to consolidate logs generated by elastic load balancers (ELBs) in the app dev, app test and app prod accounts. The logs should be stored in an existing Amazon S3 bucket named S3 EIB logs in the central AWS account. The central account is used for log consolidation only and does not have ELBs. Deployed ELB logs must be encrypted at rest. Which combination of steps should the solution architect take to build the solution? Select two options. Option A. Update the S3 bucket policy for the S3 ELB logs bucket to allow the S3 put bucket logging action for the central AWS account ID. Option B. Update the S3 bucket policy for the S3 EIB logs bucket to allow the S3 put object and S3 delete object actions for the app dev, app test, and app prod account IDs. Option C. Update the S3 bucket policy for the S3 ELB logs bucket to allow the S3 put object action for the app dev, app test, and app prod account IDs. Option D. Enable access logging for the ELBs. Set the S3 location to the S3 ELB logs bucket. Option E. Enable Amazon S3 default encryption using server-side encryption with S3 managed encryption keys SSE S3 for the S3 ELB logs S3 bucket. Correct answer is option A and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is using a single AWS region or its e-commerce website. The website includes a web application that runs on several Amazon EC2 instances behind an application load balancer ALB. The website also includes an Amazon DynamoDB table. A custom domain name in Amazon Route 53 is linked to the ALB. The company created an SSL TLS certificate in AWS Certificate Manager ACM and attached the certificate to the ALB. The company is not using a content delivery network as part of its design. The company wants to replicate its entire application stack in a second region to provide disaster recovery, plan for future growth, and provide improved access time to users. A solution architect needs to implement a solution that achieves these goals and minimizes administrative overhead. Which combination of steps should the solutions architect take to meet these requirements? Select three options. Option A. Create an AWS Cloud Formation template for the current infrastructure design. Use parameters for important system values, including region. Use the Cloud Formation template to create the new infrastructure in the second region. Option B. Use the AWS Management Console to document the existing infrastructure design in the first region and to create the new infrastructure in the second region. Option C. Update the Route 53 hosted zone record for the application to use weighted routing. Send 50% of the traffic to the ALB in each region. Option D. Update the Route 53 hosted zone record for the application to use latency-based routing. Send traffic to the ALB in each region. Option E. Update the configuration of the existing DynamoDB table. By enabling DynamoDB streams, add the second region to create a global table. Option F. Create a new DynamoDB table. Enable DynamoDB streams for the new table. Add the second region to create a global table. Copy the data from the existing DynamoDB table to the new table as one-time operation. Correct answer is option A, D, and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has a serverless application comprised of Amazon CloudFront, Amazon API Gateway, and AWS Lambda functions. The current deployment process of the application code is to create a new version number of the Lambda function and run an AWS CLI script to update. If the new function version has errors, another CLI script reverts by deploying the previous working version of the function. The company would like to decrease the time to deploy new versions of the application logic provided by the Lambda functions and also reduce the time to detect and revert when errors are identified. How this can be accomplished? Option A. Create and deploy nested AWS Cloud Formation stacks with the parent stack consisting of the AWS CloudFront distribution and API gateway and the child stack containing the Lambda function. For changes to Lambda, create an AWS CloudFormation change set and deploy. If errors are triggered, revert the AWS CloudFormation change set to the previous version. Option B. Use AWS SAM and built-in AWS code deploy to deploy the new Lambda version. Gradually shift traffic to the new version and use pre-traffic and post-traffic test functions to verify code. Roll back if Amazon CloudWatch alarms are triggered. Option C. Refactor the AWS CLI scripts in a single script that deploys the new Lambda version. When deployment is completed, the script test execute. If errors are detected, revert to the previous Lambda version. Option D. Create and deploy an AWS CloudFormation stack that consists of a new API gateway endpoint that references the new Lambda version. Change the CloudFront origin to the new API gateway endpoint. Monitor errors and if detected, change the AWS CloudFront origin to the previous API gateway endpoint. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.